So now let's consider the Gibbs free energy of, say, a chemical reaction. So if we have some reaction we can calculate the Gibbs free energy of the reaction by its definition, delta H minus T delta S, as we saw before. Definition, and so this is an important equation that you want to know and be able to use. The Gibbs free energy change is equal to the enthalpy change minus temperature times the entropy change. If we want to know what delta G for a reaction is, we would need delta H for the reaction, and we would need delta S for the reaction. Then we can put those into this equation here, knowing the temperature. We'd have to know what temperature we're performing the reaction at, and we can calculate delta G for the reaction. Another way is to use delta G formation of compounds and substances. So delta G formation is very similar to the enthalpy of formation. Since it's a relative scale, we define the 0 point as delta G of formation is equal to 0 for all elements in their most stable form. So the delta G of formation of, say, oxygen gas in O2 form would be equal to 0, just like for delta H formation. So delta G reaction can be the delta G of formation of all the products minus delta G formation of all the reactants. Now, just as with delta H, you have to multiply by the number of moles. So if you get delta G formation of, say, methane from a table, it will have units of kilojoules per mole. So when you calculate delta G of reaction, you have to multiply by the number of moles of each product and each reactant.